Okay, I'm gonna go through this and so I can get it out for you guys. Okay, this is the practice test I just posted. I also posted the answers. All right, so we've got an amine, um, and we're gonna name this with the easiest naming, which is going to be the amino group is going to be a branch. Okay, so it's a 9-carbon backbone. So it's going to be a nonane with a branch at carbon number 2, and that's going to be a N dimethyl amino 2 nonane. Okay, this is based on aniline. So this is going to be an N-diethyl aniline. Okay. So this is an amide, and it's got a 8-carbon backbone. And no branches off the amino group. And we've got a branch at 3 with a methyl group. 1, 2, 3, 4, 5, 6. Okay, ammonium chloride. So ammonia means it's going to be a positive ion coupled with the negative chloride ion. So we've got chloride, and then we've got, now this has got 4 bonds to the ammonia. So we have NH, and we've got a ethyl. Oops, let me draw that. We have a methyl, and we have a propyl. Okay, and then 3-propyl aniline. There's aniline. 1, 2, 3. Okay. Pentaamide. And we have 2 methyl groups coming off of the nitrogen. And carbon number 2, we have a phenyl group. Now, this one here, we've got a dipeptide, leucine phenylalanine, and it says draw both structures. Okay, if we synthesize this in a test tube, we're going to get a 50-50 mix of first the leucine, then the phenylalanine, and then also another 50% of the phenylalanine and the leucine. So let's draw the leucine first. I'm going to draw it as the Zwitter ion. That will be first the leucine, and then the phenylalanine. Okay, and then we're going to swap these two, where on the N-terminal end, we're going to have the phenylalanine. And again, this is outside the body, non-enzymatic. Okay, we have aminopentane. So backbone is 5 carbons. With a It looks like on the answers, I have NH. It should be NH2. So make sure you make that correction. Okay. Two common biological molecules are amides. There's a whole bunch of them. Any um, there's a question. Okay, so name two biological molecules that are so any polypeptide like insulin, protein, enzyme, like lactase, for example, protease, lipase, any protein you could, all those are polypeptides. Okay. Okay. Intermolecular forces, IMFs. Okay, so they all have London dispersion forces. Okay, this has got just LDF only, nothing else. This has got hydrogen bonding and dipole, dipole. This has got dipole, dipole, oops, besides the LDF. And this has got H bonding and dipole, dipole. Okay, so rank the boiling points. Okay, so the ones with the highest IMF are going to have the highest boiling point. So that's going to be the acid. Next is the alcohol. Next would be the amine. Then the aldehyde. And last would be the alkane. Why? Um, strongest generates the highest boiling point. Okay, so draw these two structures. Okay, so this has got LDF, both of them. This has H bonding with the nitrogen. And dipole, dipole, H bonding, dipole, dipole. Okay, so water is very polar. So the one with the highest IMF is going to be, so really the only difference between these two is the strength of the hydrogen bond. Okay, so this one has stronger hydrogen bonding. Hence it would be more soluble in water. Okay, so we're looking at an alkaline or basic pH. So at pH greater than 7, we've got acetic acid, and that's going to look like this. And then we have trimethylamine. It's going to look like this. And then if we talked about a acidic In an acidic environment, the nitrogen is going to be protonated. So in a basic environment, the acid is ion. In a acidic environment, the amine is ionized. Okay, so now we have some reactions. And if we redraw this like that, okay, naming this is going to be ethyl methylamine. Okay, in water, what's going to happen is going to form a base. And this would be ethyl methyl ammonium. Okay, so we've got the acid chloride, so that's benzyl chloride plus ethyl methylamine, and that's going to form an amide. And that's going to be NN ethyl methyl benzyl amide. Okay, remember with esters, there are three ways to create an ester. With amides, there are only two. Okay, so we're starting with, this will be the backbone of the acid part. And then we have the secondary backbone over here. Okay, so let's start with the acid one first. So we've got so that's going to be 2-methyl butyl chloride with dimethyl amine. And we're going to make N dimethyl butamide. Okay, and then we're going to use the anhydride So that's going to be the 2-methyl butyl and hydride. I'm going to make it the NN dimethyl. So this is going to be the most yield, just like with esters. Okay, enzyme moderator. Okay, that's a molecule that binds externally to the enzyme. But not in it. Okay. One inhibits, the other activates the active site. Okay, why are amino acids not named as their acidic name, but their salt? Okay, so at physiological pH 704, that's slightly alkaline. So we're going to end up forming the consider ion. So it has amino N, protonated, positive charge, acidic end, negative charge. Okay, what does an enzyme do in your body? Enzyme is a organic catalyst, and catalysts lower the activation energy. So if we did a diagram, where this is energy, potential energy, or Gibbs free energy, you're going to get a curve like this. So this is the reactants, products, and in the blue would lower activation energy. Activation energy is the energy required to get the reaction going, break the bonds of the substrate or reactants. This then speeds up the reaction. Okay, looking at a folded protein here, we've got 4 different kinds of cross-linking. So this is IDF, which is the weakest. Covalent is going to be the sulfur sulfur to sulfur oxidized crosslink. So that's going to be the COVID one is going to be the strongest. So we're going to start with then we have ionic, and we have hydrogen bonding, and we have IMFs. Okay, that's it for the practice test. And your test is going to be, like always, similar, um, different structures, but basically same.